Hello, everyone, and welcome to Expanding from Manufacturing Engineering into Design. My name is Patrick Hartnett, and I'm a Customer Success Manager here at aPriori. This morning, I am fortunate to be joined by Stan Croker, who's led the aPriori deployment at AGCO over the last decade, and is here this morning to update us with continued progress at AGCO. All right, let's begin, Stan.
Thanks, Patrick. Well, welcome everybody. Good morning, good afternoon, and good evening, wherever you happen to be in the world. My name is Stan Croker, and I'm from AGCO Corporation, and I've been involved with aPriori for a long time. I'd like to tell you now about our current project, which is to bring our design engineers into our aPriori world using the digital factories that have been created by our manufacturing engineers. So I'll start off by telling you a little bit about AGCO and then the grain and protein division, then an update about our digital factories, a little bit about our vision for the automation in design and how that fits into our projects, and then the details of our project. So AGCO itself is a global agricultural equipment company designing and building a full line of equipment for farmers. Our full line brands include Fendt, Massey Ferguson, Valtra, and Challenger, along with many smaller lines. Our task is to build machines and software tools to enable the farmers of the world to feed our population. The grain and protein division is within AGCO. They are focused on the storage of grain, the conditioning of it, moving it, and overall management of the systems that do this work. Examples of products would be equipment to feed a chicken house. This would include not only the bins external to the building, but all the bits and parts that are needed to bring the food and water inside to each of the chickens. The other end of the project size spectrum would be a set of storage bin and grain handling equipment at a port to load ships and barges, taking grain from train cars or trucks and loading it in for shipment around the world. So last year at this conference, Scott Eyman and I presented our work to build out the digital facilities for North America. The project goal was to develop a standard method for setting part manufacturing standards. This included a site in Alabama, one in Nebraska, and 3 in Illinois. I'm happy to say the project has gone very well. We are well along in our work and have checked most of the items in our phase 1 checklist. There's still work to do around getting accounting up to date and changing the standards, but the digital factories are in use at all locations. And just as a reminder, our initial task was to develop the logic to repeatedly calculate cycle times and machine routings. For a manufacturing engineer, cost means how many seconds will the part be on this first machine, and then how many seconds will it be on the second machine. It all comes down to running the factory, and that means knowing how much of your machine capacity will be busy making these parts. However, if you move upstream or to the left on the part cost maturity graphics that you've seen, you get to the design world where cost means dollars and cents. And that is the current part of our task with the digital factories, to put the correct overheads and process rates to accurately calculate not only the cycle times, but also the dollars and cents for our parts. This slide presents just a few details on the digital factory build out that we've had within the grain and protein division. The rows are the processes and machines in our factories. The columns are the specific sites. Anything with a dash means the process isn't at that location, and the green squares are fully calibrated processes and machines. The yellow triangles are the ones that are still needing some calibration work, and the red squares are not yet configured. Further, the squares that have the green fill are fully run through the bulk costing process. Let's go back a page. What? Hang on. Fully run through the bulk costing process. And this means that we've run all the parts in the factory through the new cost standards to be ready to reset those standards when the accounting is ready to change the business. So in general, what you see here is a full set of digital factories that line up with our facilities in North America. So now it's time to get the design team involved. So introducing the designers to the digital factory. When we were at last year's conference, there was an introduction for the Cost Insight Generate tool, and it struck me as something that would benefit us at AGCO. We just needed to find the right set of projects to get started on. Well, we found it. So in this picture here, you will notice the grain bins, but specifically notice all of the gantry and ladders that go across the top of the bins and down to the ground. There's a project within the grain and protein group to take and reconfigure the product lines around this. So this is a lot of what you would have as a project bid for the grain and protein group. In an effort to get more efficient at bidding, designing and building these projects, we have several projects ongoing, and one of them is to include automated costing in the grain and protein design team. To meet the schedules for this project, there's some automation that will certainly be required to support the release and planning of over 70,000 new part numbers. By automating the initial costing of these parts with the Cost Insight design process, we can take and help get those parts through design engineering and into the business itself. Not only that, it gives the designer insight to the cost of their parts, and it provides an initial look at the routings for the manufacturing engineers. So I want to pause at this moment and see if there's any questions that have come up so far. Patrick, anything?
Nothing in the chat log yet, but I know one question that's come up historically is what lessons learned do you have in terms of getting manufacturing engineering involved with design engineers? How do you best approach bridging that gap?
That's a good question. How do we take and move from manufacturing into the design world? And there's probably two items that are important to this answer. The first is that the aPriori group inside of grain and protein were represented at a pretty high level within the division at a site staff level, and that gave a lot of visibility to the tools at the meeting, so that conversation about aPriori was part of doing business and running the factory at the grain and protein sites. So the other thing is that the project that we had was involved with not only manufacturing engineering to build out the factory, but also was part of the accounting request, because the original drive came from accounting to take and standardize part standards across the whole division. So the other thing that involved was that we have a project that came along here that was very large and was going to be extremely difficult to do with the processes that were in place at the time. So we needed to find a new way to take and move 70 to 100,000 part numbers through the design process and into the business. And in the process of being able to consider how we were going to do that, aPriori was one of the things that came up, and the idea of adding this automation to the process. It was a nice coincidence of a gathering of items together. Well, let's go back to the presentation here and take a look at our vision for automation. I'm going to start in the blue box here, and in the simplest terms, the story is like this. The designer designs and does their work, and as they check in the parts to the business system, to the PDM system, the system notices that there are new parts, and it runs a cost analysis on them. And to close the loop, a report would be sent back to the designer with this cost information. Specifically, it should be able to notify the designer if any of the parts have manufacturing issues. Also identify which parts are outliers when you compare it to similar parts, either in the project or in the same factory. So in my mind, this is what I heard when I heard the description of Cost Insight Generate. And this is a really useful concept. Many of our design sites, especially our grain and protein sites, each of our engineers is responsible for a lot of part numbers, and there isn't really time to focus in a lot of detail on parts. It's just important that they get a lot of parts released because there's just a lot of different pieces of steel in these products. And so when you have a lot of part numbers that you're responsible for, it's impractical to consider doing a deep dive cost analysis wise on each one of the part numbers. And so being able to have the system go back and tell you these parts are outliers, these parts have manufacturing issues, these parts didn't cost because of some features. It's important now that the engineer can focus on their design work, and the aPriori system can take and focus on the costing piece and then identify which of those parts are interesting for the engineer to go back and look at. So in addition to the automation piece, this project brings real-time cost information into the design engineering group, and it has not had that information before. We want to be able to utilize the cost information, but at the same time, the project schedule has been developed using our current capabilities, so we need to not disrupt the design cycle. This is an interesting case where we're adding useful information like manufacturability and an estimated cost. I find it fascinating to watch what happens in these processes as new details are introduced into them, to see where the engineers and managers take this new information and how it ends up improving their designs. So let's take a look at the details of the data flow in the cost insight generate process. The design engineer creates a part, checks it into the PLM system. PLM system picks up on it, works with aPriori to cost the parts. This information is stored back in the PLM system, and then there is an email that goes back to the design engineer to notify them of the status of the parts, and the design engineer can click on those links to go find out what the story is or any additional details. Well, in reality, we needed to change a few things. So the cost insight generate process is designed by aPriori is focused on the use of WT parts. And we don't have WT parts implemented in Windchill, just Creo files at our grain and protein sites. So we're building a new process around the CAD files. The designer will have an assembly or a weldment up on screen and run a map key in Creo. The map key will back up the files to a network folder and begin to write a spreadsheet out for aPriori to use to auto cost the parts. Very similar to like a bulk load. The data spreadsheet will be presented to the user, giving them the opportunity to complete any blank fields that aPriori needs to complete the cost analysis. So if you're familiar with aPriori, when you start costing a part, there's a tab on the left side of the window where you get to fill out what BPE to send it to, what design factory, what material to use, what's your annual quantities, the lifespan of the part. All of these pieces of information have to be put into this spreadsheet. For example, if the part is a sheet metal part, then we can read the material parameter in Creo, and the cost data spreadsheet tool can decide that it's a sheet metal part and enter that as the process to be used for costing. But it won't work for every material call out. So there will be some times when the designer is called on to make a final determination for these questions. In addition to the process, aPriori needs to know additionally the material, the annual volume, the life of the part. Our system tools will be able to make some intelligent guesses for these fields, but it's still useful for the designer to look over the sheet. For example, if I have a little bracket that goes on every step that is part of my project, that's quite a few part numbers or quite a few parts that'll be produced annually as opposed to some special bracket that is used at the top of every one of the towers. These two parts have very different annual quantities. And it's up to the engineer to identify that and tell aPriori about that, because it plays into how the process is selected. So let's go back here to the big picture. So once the parts have their cost work complete in aPriori and they're saved into the database, an email will be generated and sent back to the designer telling them the status of the cost part. At this point, then they can see if there's any design for manufacturing issues, if there's other issues that should be addressed, like something that didn't cost. And of course, they will know what the cost is of the part, which is very interesting. Our project is planned to deliver some metrics and outcomes that not only benefit design engineers at Grain and Protein, but all of AGCO. First is the migration to the cloud solution, which is the requirement for Cost Insight Generate. All global AGCO aPriori users have always gone to a single aPriori server when they run the software, and that server has always been located in North America. I'm expecting to see some much better response time for our Brazilian colleagues, along with our teammates in Europe. Second, by having manufacturing process feedback built into the costing process, the engineers should be able to anticipate manufacturing issues in the factories that the factories are going to have with their new designs and alter the design to better fit in the factories. By not having the features in the design that cause the problems in the factories, we make a better product and we'll have fewer changes to have to go back and fix later. Third, over time, the advantage of having real-time cost information in the design group will help us get better at the process of bidding work and building it. And finally, by having the cost information available for everything in the factory and the design, it is time to then do some deep analysis of the designs. Where are our outliers in our current products? What makes some parts more expensive than others? Do we have places in our factories where we're more efficient? And can we route more parts through processes like that? This information lets us guide the design towards the capabilities of the factories that we have in our best possible ways. It's a unique project when you get to cross between different departments, and in this case, manufacturing and design. We have a team that's very focused on using the digital factories that we've already developed and bringing that cost information into the design world. Thank you very much for your time. And if there's any questions at this point.
All right, Stan. So we got a few questions in the chat log, which I'll call out. And then additionally, the chat panel's still open, so feel free to enter questions as we go. It looks like we've got about 10 minutes, so we'll get through as many as we can here. What type of PDM system are you using at AGCO?
Windchill. We use Windchill.
Okay.
From PTC.
Yep. All right. And then the next question is, how do you automate the cost? Do you have a fixed amount of parts to be manufactured in order for the automation to work?
So aPriori has a tool called bulk costing that they've used for a long time, which is what kind of the underlying aspect of what we're going to do initially. So I should say we've got several projects ongoing at Grain and Protein, one of which is to upgrade their Windchill system to 11.2 and then add WT parts to the mix. That's about at least a 12-month project. And so by this time next year, we should be able to just adopt the standard process for Cost Insight Generate. Until then, we're going to use what amounts to a watched folder and a bulk load process where the engineer will say, I want to cost these parts. The scripts will take and set them aside on the file system along with all the information they need, the spreadsheet to take and run the information. And aPriori will then run a script, say every hour, every minute, however much time it needs to be, and then it'll take and run those parts through the process.
And then these two questions are somewhat related and I think close to what you just hit on. So one is, how is the system determining the quantity of parts over X years and the manufacturing sites? And then if a part fails to cost during the automation, how are you tackling that failure?
So the annual quantity is one of the pieces of information that the user will enter. we'll set up some defaults. And so if you're working on this particular project, or there will be some defaults that'll happen just as the spreadsheet opens up, so that there aren't necessarily blanks in the spreadsheet. So if the user does nothing at all, they would get the default information, and if they need to change it or think to change it, then they would get more detailed information. What was the second question?
If there was a cost failure, how would that be responded to?
So the way that works is that as part of the cost report that comes back from the automated costing is information about whether the part was completely costed, or all of the GCDs addressed. And if they aren't, then that throws an error flag. And so then the step is to go take a look and see what is that feature that's not working, because that usually ends up being something in the CAD model or something like that that's or process. It's just sent to the wrong process.
All right, so we got another question related to the input sheet. Do you request that the user enter the manufacturing process, such as machining sheet metal, etc.?
Yes, they're going to have to do that. We're going to be able to make some guesses. For example, if you've got sheet or plate material or something galvanized, those material callouts are stored in our CAD models as parameters, and we'll be able to identify some of those parameters and just based on the material itself, know that it's a sheet metal part. Probably the same with plastic. It becomes a little sketchier when you start looking at the machine parts and some of that. So we'll be able to guess on some, but not all.
Yep. Okay. And then question from the Zoom chat. Where are these factories based? Are they in-house processing or outside suppliers that you're replicating?
These are all in-house factories. 3 in Illinois, 1 in Omaha, Nebraska, and 1 in Bremen, Alabama. The longer term plan is then to expand this into in-house factories that are overseas also.
And then the next question is the system capable of sending emails to multiple areas at once? Multiple disciplines at once, such as the design engineer, the cost engineer, or others within the organization?
I believe so. I'm thinking that we can just say, I said any number of people.
Yep. Got another question from the Zoom chat. How are you handling costing family tables? Is there a separate report for each instance?
So what we're doing with family tables, and they are a little challenging when you're doing the bulk costing, because the file itself doesn't exist in the file system. So our automation, if there's a family table in the assembly that we're going to cost, or one of the parts we're going to cost, is we're going to actually break it out as a separate file and store it as a standalone model in the file system, so that each of those works. I believe that's kind of a limitation for the file system based process we're using. I don't know that exists in the WT part based out of the box process.
All right, and then I got a question that's also probably related to the input spreadsheet. So how are you capturing processes that are not included in the CAD model?
Oh, so that would just have to be up to the engineer to understand that this part gets hardened or this part needs to get painted or something like that, and they would have to add those processes to the spreadsheet. So we'll require some diligence on the engineer's part. These will also be looked at by a larger team. Certainly initially we'll have a lot of people that'll pour over these numbers along with the manufacturing people, and they will certainly identify different details that have been missed and need to be added to get a good cost.
All right. That looks like we exhausted the Zoom chat, but a couple other questions here while we got some time. So these are questions, I guess, from me based on your longevity with aPriori. What are some historical lessons learned that you've been able to leverage as part of your deployment?
Well, so one of the things is, so we've been with aPriori since 2007, and had a good presence. We've actually been quite useful. So our manufacturing teams in the United States actually picked up on aPriori very quickly. And it was a matter of they had some existing spreadsheet tools that just were kind of like what we're seeing with grain and protein, where there wasn't consistency. If you handed two different manufacturing engineers the same part, you would get two different time standards because of the way they did the costing. And so in the idea of being able to move the knowledge from the previous generations into the current business, aPriori really essentially allows us to then take that manufacturing knowledge and put it in the tool and provide it to other manufacturing engineers, or as we're doing here, we can put that information in the hands of the design engineers, and so they can then take a look at and get at least an initial idea of how a manufacturing engineer would cost a part.
Great. All right, we got some more questions into the chat log now. These two might be related. So please comment on standard hardware part costs. And then, are you costing assemblies?
We are not costing assemblies in the automated way, although our manufacturing engineers are costing assemblies as a process of putting the time standards together. The other piece was about standard hardware. And what we're going to do for that is, because we don't actually make hardware, we just purchase it. We will take and load the cost information from our business system in, so that this nut costs 12 cents and the process doesn't matter. It's just a 12-cent cost when you roll it up into the assemblies.
Okay, perfect. And then we've got two questions that are probably also related. Who is responsible for looking at error and aPriori of uncosted geometric cost drivers, the designer or a cost engineer or somebody else? And then, do you have a dedicated costing group, or is it available to every engineer?
So speaking of grain and protein, it will be available to every engineer. Within the different divisions of AGCO, it varies. We've got some costing groups that have been built up. Every one of our vehicle sites has a costing group, and we're building that infrastructure with this project. That's another part of what we're doing with grain and protein, is to build that costing infrastructure into it. But every design engineer will have access to the aPriori costing tools, and if anything doesn't cost, we'll certainly have a set of admins involved, and some of the experts from the manufacturing side early on, as we identify the kind of things that don't cost, because they tend to be the same thing over and over, and then we'll just roll that into the training for the engineers and get past that and move on to the next thing.
Excellent. All right, so we've got just about a minute left. So Stan, I wanted to thank you for taking us through that session today. I think it was a great kickoff to the event.
Thank you.